These benchtop system design, data collection, and analysis principles can be used as a rational foundation for the in vitro study of cavitation-enhanced therapies. Our techniques enable high-throughput testing while preserving the critical experimental attributes of integral cavitation monitoring, repeatable sample alignment, and compatibility with common cellular analysis methods.
Cavitation-enhanced therapy has multiple potential applications, including the treatment of diseases such as cancer and stroke. By better understanding the underpinning mechanisms, we can develop better therapies.
This work provides an easily reproducible system design and implementation framework to allow research into a wide variety of cavitation-induced cellular bioeffects, including drug delivery, sonoporation, and sonoprinting.
Getting a meaningful result requires ensuring reproducibility and controlling for all variables in the experiment. It is imperative to perform all the relevant controls and measure the electrical noise.
For preparation of the systems for acoustic transfection, degas the fill liquid under a pressure of -100 kilopascals for at least 2 hours to minimize the likelihood of cavitation in the propagation path. Confirmation with a dissolved oxygen probe that the partial pressure of oxygen is below 10 kilopascals is recommended. Fill the test chamber slowly to minimize the reintroduction of air into the degassed liquid, and immediately clear any residual bubbles from the transducer and medium container surfaces. Allow the ultrasound source power amplifier to warm up per the manufacturer's recommendation so that the gain and output are stable with respect to time. And dilute the cavitation agent while gently and continuously